Hi children, welcome to new session. I am Arnelveni, Mathematics CRT, Laveri KGBV, Srivakalam district. We are going to discuss about the elements of geometry for 9th class. We may have seen large structures like bridges, dams, school buildings, hospitals, hostels, temples, etc. Geometric principles involved in these constructions. We also know that geometry is widely used in daily life activities like paintings, handicrafts, layout floor design, fluffing and showing of seeds in fields. So we can say that the life without geometry is unimaginable. The great constructions like pyramids in Egypt, the Great Wall of China, Taj Mahal, Charminar, Eiffel Tower of France, some of the best examples of applications of geometry. We should know the basic elements of geometry and its application. Our topic is the elements of geometry. What is geometry? Geometry word derived from Greek. Derived from Greek. Geo means earth. Metron means measure. In geometry, there are undefined terms like point, plane, and line. Angles, circles, and triangles are the examples for defined terms. See shape of cuboid. Cuboid has three dimensions: name, length, breadth, and height. This is surface. How many surfaces of cuboid? 1, 2, 3, 4, 5, 6. 6 faces of cuboid. This is edge. How many edges of cuboid? 1, 2, 3, 4. Bottom also 4. Sides also 4. Total 12 edges. This is corner. This is corner. How many corners of cuboid? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners. 8 corners. Corners means vertices. This is cuboid shape. It has 3 dimensions: length, breadth, height. If it loses one dimension, that is height, it will have only 2 dimensions like which is rectangle. We know that rectangle has length and breadth. If it loses another dimension, that is breadth, it will have only line segment. It also loses more dimensions, remaining only points. Chapter we have to know about Euclid. The Euclid of Alexandria in Egypt wrote 13 books called the Elements. Euclid developed fundamental definitions, axioms, postulates, and theorems. Some definitions of Euclid are: a point is that which has no part. A line is breadthless length. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of surface are lines. A plane surface is a surface which lies evenly with the straight lines on itself. Next, axioms. In mathematical, statements are two types: true, false. For example, 4 plus 2 is equal to 6. This is true. False. 4 plus 2 is equal to 8. This is 2 times. With proof, without proof, with proof. Without proof, 4 plus 2 is equal to 6. Need not yet proof. With proof, root 2 is an irrational number. This is axiom. This is postulate. Some of the axioms of Euclid. Things which are equal to the same things are equal to one another. That means A equal to B and B is equal to C. Then A is equal to C. Then A is equal to C. If equals are added to equals, the wholes are equal. For example, A is equal to B, C is equal to D, and add them. A plus C is equal to B plus D, also equal. If equals are added to equals, the wholes are also equal. If equals are subtracted from equals, the remainders are also equal. For example, A is equal to B, C is equal to D. Subtract them. A minus C equal to B minus D. Things which are double of the same things are equal to one another. For example, A is equal to B. Double them. 2A equal to 2B. Things which are double of the same things are equal to one another. Things which are halves of the same things are equal to one another. Things which are halves of the same things are equal to one another. For example, A is equal to B. Halves means divide by 2. A by 2 is equal to B by 2. Things which coincide with one another are equal to one another. Things which coincide with one another are equal to one another. I will repeat the Euclid's axioms. Things which are equal to the same things are equal to one another. If equals are added to equals, the wholes are equal. If equals are subtracted from equals, the remainders are also equal. Things which coincide with one another are equal to one another. Things which are double of the same things are equal to one another. Things which are halves of the same things are equal to one another. To draw a straight line from any point to any point, mark 2 points A, another point B. Draw a straight line through these 2 points. How many straight lines can be drawn through these 2 points? You cannot draw more than one distinct line through given 2 points. Only one line. Postulate 2. A line segment can be extended on either side to form a straight line. First of all, draw a straight line. Line segment. Draw a line segment PQ. Extend both sides. Extend both sides. Does it have any endpoints? No. A line segment can be extended on either side to form a straight line. Postulate 3. We can describe a circle with any center and radius. Take radius are given 3 centimeters, 4 centimeters, 5 centimeters. By using compass to draw a circle. 3 centimeters, 4 centimeters, 5 centimeters. Postulate 4. All right angles are equal to one another. Right angles. All right angles are equal to one another. Postulate 5. If a straight line following on two straight lines makes the interior angles on the same side of it taken together is less than two right angles, then the two straight lines, if produced infinitely, meet on that side on which the sum of the angles is less than two right angles. If a straight line falling on two straight lines makes the interior angles on the same side of these are two lines. This is transversal line. These are interior angles on the same side of it. Taken together is less than two right angles. Then the two straight lines, if produced infinitely, meet on that side on which the sum of the angles is less than two right angles. Equivalent versions of Euclid's fifth postulate. Through a point not on a given line, exactly one parallel line may be drawn to the given line. This is called John Playfair axiom. LBA, let LBA line. LBA line. PBA point, not on L. Through P, exactly one line exactly one line parallel to L. Parallel to L. This is called John Playfair axiom. The sum of angles of any triangle is a constant and is equal to two right angles. Angle 1 plus angle 2 plus angle 3 is equal to 180. This is a legendary postulate. There exists a pair of lines everywhere equidistant from one another. Positronous postulate. Everywhere equidistant from one another. Like there exists a pair of lines everywhere equidistant from one another. Equidistance. If a straight line intersect any one of two parallel lines, it will intersect the other also. This is a Proclus postulate. Pair of parallel lines intersect another line. If a straight line intersect any one of two parallel lines, it will intersect the other also. The statements that were proved to be true are called propositions or theorems. The statements that were proved to be true are called propositions or theorems. The statements neither prove nor disprove are called conjecture. The statements neither prove nor disprove are called conjecture. For example, every even number greater than 4 can be written as sum of two primes. This is Goldbach conjecture. Let us discuss exercise 3.1. Look at the page number 68. First Roman, answer the following. First question. How many dimensions a solid has? Already told. How many dimensions solid has? Solid has a 3 dimensions, namely length, breadth and height. The solid has 3 dimensions. Namely length, breadth and height. Second question. How many books are there in Euclid's Elements? How many books are there in Euclid Elements? Euclid Elements, 13 books. How many elements are there in Euclid Elements? 13 books. There are 13 books in Euclid Geometry. Books, Euclid's Geometry. Next question. Third question. Write the number of faces of a cube and cuboid. Already told how many number of faces cuboid has. 6 faces. And cube also 6 faces. Cube 6 faces. cuboid also 6 faces. Next question. What is sum of interior angles of a triangle? The sum of interior angles of a triangle is right 180 degrees or supplementary. The sum of interior angles of a triangle is 180 degrees. Fifth question. Write three undefined terms of geometry. Euclid undefined terms like line, point, plane. Euclid undefined terms are point, line and plane. Okay. Second Roman. State whether the following statements are true or false. Also give reasons for your answer. First question is, only one line can pass through a given point. Only one line can pass through a given point. This is a false statement. The line can pass infinite lines through a given point. The line, infinite lines can pass through a given point. How many lines can pass a given point? Infinite lines. Like. So first one is false. Reason: infinite lines can pass through a given point. Second one. All right angles are equal. All right angles are equal. This is true. All right angles are equal. Third question. Circles with same radii are equal. This is also circle with same radii are equal. This is also true. This is also true. Fourth one. A line can be extended on its both sides endlessly to get a straight line. Already told postulates. Euclid postulates. A line can be extended on its both sides endlessly to get a straight line. This is also a true. Fifth one. Question. From the figure, A, C, point B. Okay. From the figure, AB greater than AC. AB greater than AC. AB greater than AC. Euclid definitions. The whole is greater than part. The whole is greater than part. So, AB greater than AC. This is true. AB length is greater than AC length. Third Roman. In the figure given below, show that length AH is greater than AB plus BC plus CD. See this figure. AH, this is a AH line. This is, you understand? This is a AH line. AH greater than AB plus BC plus CD. So, to prove AH is greater than to AD. Solution. Given AH greater than AB plus BC plus CD. AH greater than AB plus BC plus CD. To prove AH is greater than AB plus BC plus CD means AD. AH is greater than AD. We have to prove AH is greater than AD. Okay, from the figure, AD is equal to, how to write? AB plus BC plus CD. AB plus BC plus CD. AD is equal to AB plus BC plus CD. Okay, AH greater than AD. AH greater than AD means this is a Euclid adjacency. The whole is greater than the part. So, we have to prove AH greater than AD. AH greater than AD. AD means AB plus BC plus CD. Fourth question. If a point Q lies between 2 points P and R. 2 points P and R, such that PQ is equal to QR. PQ is equal to QR. Prove that PQ is equal to half of the PR. PQ is equal to half of the PR. If a point Q lies between 2 points P and R. Solution. Q point lies between 2 points P and R. Okay. We draw P and R line. P and R. This is a P point R point line. P point R point. A point Q lies between 2 points P and R. Okay. Q is lies between P and R, such that PQ is equal to QR. So, PQ length is equal to QR length. That is Q between P and R. Prove that PQ is equal to half of the PR. Okay. Let Q point Q lie between P and R. Let the point Q lie between P and R. According to the problem, PQ is equal to QR. PQ is equal to QR. Okay. From the figure, PR is equal to PQ plus QR. We write PQ plus QR. PQ plus QR. Okay. That is equal to PQ plus QR. QR means PQ. So, QR is equal to PQ. Right here. So, PQ plus PQ is equal to 2PQ. PQ, so, therefore, PR is equal to 2PQ. Okay. We want PQ is equal to half of the PR. So, PQ is equal to half of the PR. Already we know 2 transport to LHS. 2 transport to LHS half of the PR. To prove our problem. Fifth question. Draw an equilateral triangle whose sides are 5.2 centimeters each. This is a construction. This is equilateral triangle construction. I explain how to construct equilateral triangle. First, draw rough sketch with given measurements. Draw a rough sketch. Already we know that principles of equilateral triangle. In equilateral triangle, 3 sides are equal. This is a equilateral triangle. All sides are equal. A, B, C. Each side 5.2 centimeters, 5.2 centimeters, 5.2 centimeters. This is a rough diagram. First step, we want to construct this. First step will be draw a line segment BC is equal to 5.2 centimeters. And second one, draw a arc 5.2 centimeters radius with center B. And next step, draw a arc 5.2 centimeters radius with center C. 2 arcs intersect at A. Join A to B and A to C. We have to do this construction. You have to do this construction. Next question. What is a conjecture? Give an example for it. Already we know that conjecture. Mathematical statements which are neither true nor disproved are called conjecture. Mathematical statements which are neither proved nor disproved is called conjecture. Conjecture is nothing but hypothesis. Example, every even number greater than 4 can be written as sum of the two primes. This is a Goldbach conjecture. This is called Goldbach conjecture. Next, 7th question. Mark 2 points. Mark 2 points P and Q. Mark 2 points P and Q. Draw a line through P and Q. Draw a line through P and Q. Now, how many lines are parallel to PQ? How many lines are parallel to PQ? Give an example. Can you draw? Can you draw? Mark 2 points P and Q. First of all, mark the points P and Q. Mark 2 P and Q. Okay. Draw a line through P and Q. So, draw line through P and Q. Like this. Now, how many lines are parallel to PQ can you draw? How many lines parallel to PQ? Infinite lines can be drawn. These are all parallel lines. This is also parallel lines. Infinite lines can be drawn through PQ line. Infinite lines can be drawn. Next question, 8th question. In the adjacent figure, a line N falls on line element such that in the adjacent figure, a line N falls on lines L and M such that the sum of the interior angles sum of the interior angles 1 and 2 less than 180 degrees. Then what can you say about L and M? Figure also given. This is L line, this is M line, this is transversal line N, this is angle 1, angle 2. In the adjacent figure, this figure, a line N falls on L and M line such that the sum of the interior angles, these are interior angles, less than 180 degrees. Then what can you say about L and M? Solution. L, M are lines. N is transversal line. Okay. Already we know that angle 1 is less than 90 degree. Angle 1 is less than 90 degree. Angle 2 is also less than 90 degree. Angle 2 is less than 90 degree. If in case L line and M line produced one side, the angles 1 and 2 angles are formed. These two lines intersect at one point. So LM and lines are intersecting lines. L and M lines are intersect at one point. If line L and line M produce one side, they intersect at one point. Their lines are intersect at one point. Next question. In the adjacent figure, if angle 1 equal to angle 3, comma, angle 2 is equal to angle 4, and angle 3 is equal to angle 4. Write the relation between angle 1 and 2. So 1 and angle 2. Using an Euclid postulate. Using an Euclid's postulate. Okay, solution. Figure is given. Okay, look at the figure. In the adjacent figure, if angle 1 equal to angle 3, angle 2 is equal to angle 4, and angle 3 is equal to angle 4. Relation between angle 1 and 2 by using Euclid postulates. Okay, given angle 1 is equal angle 3 and angle 2 is equal angle 4. Angle 2 is equal to angle 4. And angle 3 is equal to angle 4. Then angle 1 is equal to angle 2. Therefore, angle 1 is equal to angle 2. By using Euclid axiom, things which are equal to same things are equal to one another. Things which are equal to same things equal to one another. Angle 1 is equal to angle 3. Angle 3 is equal to 4. 4 is equal to angle 2. Then angle 1 is equal to angle 2. By using Euclid's axiom, things which are equal to same things are equal to one another. Next question. Last question. In the adjacent figure, we have Bx is equal to half of the AB. By is equal to dy is equal to half of the BC, and AB is equal to BC, so that Bx is equal to By. So that Bx is equal to By. Figure A, B, C on the point X, on the point Y. Okay, solution. In the adjacent figure, Bx is equal to half of the AB. By is equal to half of the BC. AB is equal to BC. And AB is equal to BC. So that Bx is equal to By. We have to prove Bx is equal to By. Given Bx is equal to half of the AB, By is equal to half of the BC, and AB is equal to BC. To prove Bx is equal to By, to take AB is equal to BC. According to the problem, AB is equal to BC. Dividing both sides by 2. Dividing both sides 2. By using your Euclid axiom, things which are halves of the same things are equal to one another. Dividing both sides by 2. AB by 2 is equal to BC by 2. AB by 2 means BX is equal to BC by 2 means BY. Hence, so proved. Which principle use? Euclid exam. Things which are also equal to same things are equal to one another. Okay children, complete this worksheet by your own. I would like to thank all my higher authorities for giving me this opportunity.